Hello, welcome to those who already logged on. Great to see some numbers coming in there. This is lesson 2 of the GCSE preparation course and it's on Surds today. I'm Mrs. Kidson, going to be leading you through the content. While we wait for a few more people to log in, have a go at the starter questions. Hopefully you can see question 1 and question 2 on the right there. Make sure you've got paper and pen ready because there's a lot of questions this session. Right, have a go. Anytime you've got any questions for me, type them in the live chat box and I'll try and get back to you when I can. There is a bit of a delay on the live feed, so if I don't answer you straight away, don't worry. But try and get your question in as soon as you can so that I'll see it in time. Hi to those just joining. Just have a start at the starter questions, questions 1 and 2 on the right there. I'll go through them in a few minutes. Great to see a few more people logging on. We're just doing the starter questions on the right, and I'm going to go through them in a few minutes' time. All right, just one more minute on those questions. See what you remember. All right, welcome if you've just logged in. We are about to go through the starter questions. I could wait all day for you to all finish them all, but we need to get cracking. I'm going to go through some of them a bit quicker, some of them I'll take my time over, and some of them we'll recap a bit later in the session as well. So don't worry if I skip them. But if you do have questions, remember you can type them in the chat box at any time, and I'll try and get to them when I see them. Okay, let's have a look. Question 1. If we have a look at the first one, we get an answer of root 33. That's using our basic surds rule of multiplication. Root 3 times root 11, if they're both in surds, so both under a root, then you can just times them together. So we get root 33. Always check if you can simplify it, but there's no square number we can take out of 33, no square factor, so we leave it as it is. The next one, we get 6 root 3. And that's because if we look for a square factor of 108, so a square number that goes into it exactly, The largest one we find is root 36. 36 goes into 108 3 times. So we could rewrite root 108 as root 36 root 3. The square root of 36 is 6. So that's how we get the answer 6 root 3. Always write your square number first because it makes it simpler when you simplify it. Right, the third one, we have root 50 divided by root 2. This is another basic rule of division, and it's the same. If they're both in a surd or both under a square root symbol, just divide the numbers. Root 50 divided by root 2. We get an answer of 5, and that's because root 50 divided by root 2 is root 25, and the square root of 25 is 5. Next one, same rule, root 14 divided by root 2, we get root 7, but we can't simplify that, so we just leave it as root 7. For the next one, our answer is just 39. Square root and square are inverses of each other, so they're the opposite. So if we do root 39 and then we square it, it's like we've undone the root. We've just got back to 39. In the final one, I hope you didn't try to do 25 times 64, because the key here is to simplify first. Root 25 is just 5. Root 64 is just 8. So it's just 5 times 8. Always try and simplify first where you can. Makes it a lot easier. Right, for question 2, I'm not going to go through these in detail yet. We're going to do them on a subsequent slide, but I will show you the answers in case you had a go. For 2a, it just simplifies down to 1, so well done if you got that correct. And 2b, it's 14 plus 6 root 5. If you're not sure on any of those, just put a star next to your workings, and I'll go through it in a bit, and hopefully it'll make sense once I go through an example. Are we all okay to move on? Right. Next page then. So these are the rules we just talked about. The first one is the multiplication rule. Root a times root a equals a. Now this one is actually a specific one because it's the same root. So it's like root 5 times root 5 would just equal 5. Because root 5 times root 5, I'll just jot this on the top here as an example. Root 5 times root 5 would give you root 25 because the multiplication, and the square root of 25 is just 5. So it is just sort of undoing the root there. Root a times root a equals a itself. The next one is if you then times it by another root a, we just add a root a right next to it, and you can continue and continue multiplying by root a. This bottom two are the ones we covered in the starter. Root a times root b is root ab, all multiplied together. And the bottom one, root a divided by root b, is root a divided by b. So as long as they're both under a surd symbol, we can just do the multiplication or the division as it says. I've put some key points in here as well, because it's really important to note a few skills when we're doing this, these topics with surds. Firstly, simplify by dividing by the largest square factor. It's always got to be the largest one, otherwise it's not in its simplest form. I'll do an example in a minute of that case. So you've got to find the largest square number. Second key point is always try to simplify first. So like we saw in the starter, it was much easier if we realised that root 25 was just 5. The third one I'm going to go over in a bit more detail, and this is to treat coefficients and surds separately. So coefficients are the numbers in front of the surd. So here, with my first example, we've got 7 root 20. I'm going to leave the 7 alone for now, and I'm going to focus on this root 20. Now, we're going to simplify this, so we need to look for the largest square number that goes into 20 exactly. That's going to be 4, the square number 4. So we always write the square number first, so root 4, and then it's how many times it goes into 20. Root 4, root 5, because 4 times 5 is 20. Now, the first one of those, because it was our square number, we can simplify that. The square root of 4 is 2, so we get 2 root 5. Now we've got to remember we had that 7 there. So we've actually got 7 lots of 2 root 5, Because the 7 was right next to that surd, the root 20, it means multiplication. So 7 lots of 2 root 5, and we end up with 14 root 5 as our final answer. Okay, so in that example, we just took the surd first, we simplified that, and then remembered we had to multiply it by 7 at the end. And you'll see at the end there, we just did the 7 times 2 to get 14. We didn't touch the 5 in the surd there, because that's a surd, we treat it separately to the 7. Okay, we don't multiply between whole numbers and surds. If we look at my second example, and I'm going to take the coefficients first, the 2 times the 3, let's treat them separately. 2 times 3, and we get our 6. Then if we move on to the surds, we've got root 3 times root 8, and we get root 24. Now that could be our final answer, but we've got to check our surd, and in this case we can simplify it. Can we think of the largest square number that goes into 24? That's going to be 4 as well. So we can write that as root 4 root 6. And then we can simplify that to just 2 root 6, because the square root of 4 is 2. Now don't forget, we had that 6 originally, and that means we've got 6 lots of 2 root 6. So we've actually got 12 root 6 as our final answer. Okay, I've gone straight into some quite tricky ones there, because I wanted to show you that fact that we have to treat the numbers, or the coefficients and the surds slightly differently, and we can treat them separately. We're going to take it back a little notch now, and we're going to do some practice of simplification, and we'll see how we go on these. So, this is your turn. I'm going to do one example, and then I'm going to give you a few practice questions, and you can choose your level. You can start simple, you can go slightly more tricky. Let's do one example here. I'm going to walk through simplifying. So we've got to simplify root 48. If you can see at the top here, I've written out all my square numbers. It's good practice to do this if you struggle to picture them immediately, because you can work backwards. So 48, I'm going to look at 36 first, so that's the first square number that's smaller than it. So remember, always start from big and you'll find the biggest square factor first. 36 doesn't go into 48 exactly. 25 doesn't. 16. Now 16 always catches people out because we don't know our 16 times table. There we go, 16 plus 16 is 32. Add another 16, we get 48. So 16 is actually our largest square factor of 48. So we're going to write root 16 and then root 3, because remember it goes in 3 times. We can simplify root 16 to 4, so we get an answer of 4 root 3. Now I'm just going to show you what would happen if we didn't get the largest square factor, because you might be able to tell that 4 goes into that as well. So if I thought that root 4 was the biggest, and I worked out that 4 goes into 48 12 times, my workings would start like that. I'd then simplify root 4 and get 2 root 12. Now I know that's not my final answer, because the root 12 can still be simplified. You can see we've got another factor of 4 in there. So I could do that separately. Root 12 is root 4 root 3. 4 times 3 is 12, which is 2 root 3. But don't forget we had that 2 in front of it. So we've got 2 lots of 2 root 3, which is 4 root 3. So it is possible to still get the right answer if you take out a smaller square factor, but can you see it's a bit more complicated? We've got an extra step there and it's easy to get in a muddle. Whereas if you take out the largest square factor, which was a 16, you can do it in one step. Okay, so that's what we're looking for here. Now you've got some practice questions to try. On the bottom here are basic simplifying questions. So if this is all a bit fuzzy to you, maybe you did it a while ago or you struggled with surds from the start, which is quite common because it's a tricky topic, then have a go at some of these. If you're fine with simplifying and it's all come back to you, then try some of these questions. Slightly more challenging, but still using that same simplifying skill. There's a little hint there as well for questions 2 onwards. Alright, I'm going to mute myself for a few minutes and let you practice these, Any questions you've got, put them in the chat box and I'll get back to you. All right, see you in a few minutes. I'm just going to give you 1 more minute on those questions. All right, 1 more minute. Right, let's look at some answers. if you need any more time to practice, because obviously I'm not expecting you to have managed all those questions right then you will still be able to access this video once I stop the live recording. So go back, pause it, do it in your own time, listen to my explanations again, and hopefully you'll feel more confident. So don't worry if you don't understand it the first time round, you can always go back and listen to it. That's the joy of a recorded video. Okay, let's look at some answers and I'll go through the top row. So A here, root 12, we can simplify to root 4 root 3. Because if I look at my square numbers at the top of the page there, the largest square number that goes into 12 is 4. So I write that one first, root 4, and it goes into 12 3 times. So we write it as root 4 root 3. Then you can always simplify your square number. So the root 4 just becomes 2. 2 root 3 is your final answer. Moving on to question B. I can write this one as root 25 root 2 because the largest square number that goes exactly into 50 is 25 and it goes in twice. Root 25 I can simplify to 5, so my answer is just 5 root 2. And question C. The largest square number that goes into root 32 is root 16 and that goes in twice, so we write root 16 root 2. We can simplify root 16 to 4, so we get an answer of 4 root 2. Okay, I hope that's helped a little bit. I'm just going to show you the answers to the next ones, so you can mark any that you chose to do. Any queries with any of them, let me know. Type in the chat box as soon as you can, so I don't get too much of a delay on it. Just type the letter of the question. Going to go through the ones on the right hand side now. So these are using some of our other rules. The first one there is using that division rule, root 72 divided by root 3. Now we get root 24 because 72 divided by 3 is 24. But remember that's not our final answer because we can simplify it further. You'll see here we can divide 24 by 4, that's the largest square number that goes into it. So we get root 4 root 6, which is the same as 2 root 6. That is our final answer because we know there's no other square number that goes into 6. Someone's just said they'd like to go through G. That's absolutely fine. I'll have a look at that one. So we've got root 98. The largest square number that goes into 98 is 49. Again, another tricky one to spot, but that's because we get root 49 and it goes in twice. Oh, sorry, that's a 2. And the square root of 49 is 7, so we get an answer of 7 root 2. Okay, tricky ones to spot there, I think the 16, 36, 49. Okay. Question 2 on the right hand side, we get 4 root 3, because root 48 we have to simplify. And this is when they start to get more challenging, and that little bubble, that yellow bubble, says, remember you cannot add or subtract surds with different bases. Simplify each surd first. So you'll see there we've got root 48 minus 3 root 3. Now they have to both be root 3 for us to be able to add or subtract. Division, multiplication is fine, but adding or subtracting, just like fractions, fractions have to have the same denominator, surds have to have the same base to be added or subtracted. So root 48 we have to simplify and we get 4 root 3. We take away the 3 root 3. If I've got 4 lots of root 3 and I take away 3 lots of root 3, I'm just left with 1 lot of root 3, with just root 3. Okay, we'll have another go explaining that with this next question. We've got root 32 take away root 2. So we have to simplify that 32. Now root 32, that was our question C from the ones on the left there. Remember we got root 16 root 2 and then 4 root 2. So we've actually got 4 root 2 take away root 2 and we end up with 3 root 2. Because I had 4 lots of root 2, I've taken away 1 lot of root 2, so I'm just left with 3 of them. Okay, so it helps, I think, to think of them as lots of when you're doing those addition and subtraction. The third one is the same skill there, but it's 3 parts. Doesn't change it, just simplify them all separately. Root 72 becomes 6 root 2, minus root 2, and then root 50 becomes 5 root 2. So I've got 6 root 2 minus root 2 plus 5 root 2. Let's do it in steps. 6 root 2 take away root 2 would give you 5 root 2. Add another 5 root 2 and you've got 10 root 2. Okay? I'm just going to get rid of these examples here so I can do the last one. And the final answer, 4 root 2 is what root 32 simplifies to. And root 8 simplifies to 2 root 2. So we've got 4 root 2 plus 2 root 2, and we end up with 6 root 2. Okay, they are slightly more challenging, so don't worry if you're coming into this from really hating Surds and being very unsure. These ones are slightly trickier, but it's just using your skills on the left. We just sometimes have to simplify things first and then add or subtract. Okay, are we all ready to move on there? Let's try our next skill. Well done so far for keeping up. So, we've now got double brackets, getting a little bit trickier, but we only need our basic skills still. We need those multiplication rules, you see them on the right there, and we're going to need our simplifying. Now there's two ways that you might have learnt to expand double brackets. I'm going to try and do both quickly for you, and then choose one to focus on, but do whichever method you've learnt for double brackets. Firstly, I'm going to do the multiply everything by everything method, which is how I do it. So this 2 needs to be multiplied by that 2. 2 times 2 and we get 4. Then this 2 needs to be multiplied by the minus root 3. Make sure we're looking at those signs as well. Now 2 lots of minus root 3. It's going to be negative because there's one negative there. 2 lots of root 3 is just 2 root 3. Remember, we can't combine the normal coefficient and the surd. They stay separately, so we just write the 2 in front of the root 3. Then we move on and do root 3 times 2. So again, that's going to be positive, that one, because both of those terms are positive. So we've got a positive 2 root 3. Then we've got root 3 times minus root 3. Now my answer is going to be a negative there because I've got one positive, one negative. And if you remember the first rule over here on the right, root 3 times root 3 is just going to be 3. The surd sort of cancels itself out. Alright, now we're on to the simplifying stage. Take all your regular numbers, the coefficients that are just on their own. 4 minus 3, and we just end up with 1. Then, can you see we've got minus 2 root 3 plus 2 root 3. So they just cancel each other out. They've disappeared. Not always going to happen, but it is in this specific case. So our answer is actually just 1 out of that really complicated expression. This was that first starter one, if you remember I went through and I said we'll focus on them later. So we just got 1. Now some of you might do grid method for your expanding double brackets, so I'm just going to go through that quickly in case that method is completely alien to you. So for your double brackets, you might have instead set it out like this. In that first bracket, we've got a 2 and we've got a root 3. In that second bracket, we've got a 2 and we've got a minus root 3. Okay, so this might look more familiar to some of you. If not, it's a really nice method for doing double brackets, really simple. Then we have to fill in our multiplication grid. 2 times 2 is 4, so the 4 goes there. Then we've got 2 lots of root 3. Then we've got our 2 lots of minus root 3. Then we've got our minus root 3 times root 3, which is just our minus 3. Then you have to add those 4 terms together, and you'll see these ones still cancel each other out, and we end up with 4 minus 3, which is just 1. Same answer. It's just another way of doing it. Now I'd like you to have a go with this one. It's written a bit differently. It says write 3 plus root 5 all squared in the form a plus b root 5. And then it says where a and b are integers. Now don't worry about all the weird wording there. First thing to do when you see a bracket like that squared is you write it out twice. Do this every single time. I even tell my A-level students, write it out. You won't make mistakes then. Okay, so it's just like the first question if you write it out like that. You have a go. Okay, should we go through this? Sorry if you haven't quite had time, but let's see if you follow my method. I'm going to do the grid method, I think, for this one, as it's nice and clear. So I'm going to set up my grid with the first bracket, 3 plus root 5, and the second bracket, 3 plus root 5. Now I just need to do my multiplication. 3 times 3 is 9. 3 times root 5 is 3 root 5. 3 times root 5 is 3 root 5. Root 5 times root 5 is just 5. Remember, it cancels out the surd. Now we have to add together. Let's take our numbers first. 9 plus 5 is 14. Oops. Then we've got 3 root 5 plus 3 root 5. They don't cancel out this time because they're both positive. So we actually end up with 6 root 5. Okay, we don't do anything to the root 5s. They don't become a root 10 when they're added or anything. It's just 3 lots of root 5 plus another 3 lots of root 5. So we end up with 6 root 5. Final answer. Hope we did all right on that one. Okay. Now, let's get a little bit trickier. Hope we're still following. Now we're moving on to rationalising the denominator. This is the topic that might fill some of you with fear, but that's why we're going through it. Going to have a little go. So all this means, it sounds scary, but it just means the denominator, the bottom number in the fraction, cannot be a surd. Okay, we don't want that root x to be a square root. So we have to multiply, and we're going to use this first rule, remember on the right here? If we multiply it by itself, it becomes just its regular letter. So we're going to take our original fraction, and we want to multiply that denominator by itself, by root x. Now on the top of my fraction there, I have to have another root x, because what I want to do is I can't actually change the question, I can't add any numbers or fractions in, but root x divided by root x is the same as 1, because anything divided by itself is 1. 5 divided by 5, 1. 100 divided by 100, 1. Root x divided by root x is 1. So by multiplying the question by 1, we're not actually changing it, but it is allowing us to change its format. So the top, if we look at our numerators, the top of the fraction, x times root x. Now we just write that like this. Because remember, that first x isn't a surd. That's like our regular number, so it just stays outside of it. X lots of root x. Then underneath our fraction, we've got root x times root x, and that's that first rule over on the right there. It will just become x. Now, can anyone spot how we simplify this? You've got x's everywhere. We need to work out which ones we can cancel. It's the ones without a surd. So this one and this one can cancel each other out. And that's because everything's being multiplied together on the top. We've only got one kind of term there. X is a factor of the top and the bottom. So we're actually left with just root x as our answer. You could write it as root x over 1, but in its simplest form it's just root x. Okay, have a go then, and you try this one here for me. Rationalise the denominator of 6 over root 3. Okay, should we have a look how we've done? So we've got 6 over root 3. We need to multiply the denominator by root 3. Okay, remember we multiply it by itself in order to get rid of it. That means the top we've also got to multiply by root 3. It's this second fraction that must be the same, top and bottom. Now on the top we've got 6 times root 3, so we've got 6 root 3. And on the bottom, we've got root 3 times root 3, which is just 3. Now this we can cancel, and we can simplify a bit. And we're going to look at those regular numbers, the numbers in front of the surds. We've got 6 root 3 divided by 3, and that means we've got 2 root 3. We can't simplify the 3 in the surd because it's different to those numbers outside a surd. Can't do something to both of them all together. So we just do the 6 and the 3 and we divide them by 3. Hope that's all right. Should we try the next type? Let's have a go. Do ask me if you need to go through anything again. Now this is the same skill. You'll just notice the numerator is a little more challenging. So again, I'm going to go over one for you and then you're going to have a practice. So this one, we're going to have to multiply it by root 2 over root 2 because the root 2 is that denominator which we want to simplify, and we've got to do the same on top. Now remember, the top there is like it's got brackets around it. I hope you can see that with me drawing up there. 1 plus root 5 has all got to be multiplied by root 2. So we've got 1 times root 2, which is just root 2. Then we've got root 5 times root 2, which is root 10. Okay, so one lot of root 2 was root 2, root 5 times root 2, root 10. Underneath our fraction, we've got root 2 times root 2, which is just 2. Now it looks like we should be able to simplify that because they're all even, but remember that 2 on the bottom is a coefficient, that's our regular number, it's not a surd. So we can't simplify our surds with that number, and that's actually how the final answer is. We can't add the root 2 and the root 10 either because they've got different surd bases. You could try to simplify the root 10 if it was possible, but actually there's no square number that goes into 10 other than 1, which we don't use because it doesn't change the number. Okay, so that's actually how we leave that one. You have a go at this question for me. Okay, I'm going to start going through this one. So we've got 4 minus root 3 over root 3. We're going to have to multiply it by root 3 over root 3 to get rid of that surd on the bottom. Now on the top, remember it's in brackets there, so we've got to multiply everything by root 3. 4 lots of root 3 is 4 root 3 minus root 3 times root 3. So it's still going to be a minus. Root 3 times root 3 is just 3. Okay, so that's our numerator. On the bottom we've got root 3 times root 3, which is just 3. Now this is still our final answer. Don't be tempted to simplify. We can't simplify that surd because the denominator is not a surd. We can't interlink those. You might be tempted to simplify the 2 3's at the end because they're both normal numbers. But because that 4 isn't divisible by 3, we can't. We can't do anything. Every term has got to be able to be simplified in order for you to simplify it. So don't be tempted to simplify there because that's impossible. Okay. Hopefully some of you are still with me there because this is getting trickier, but well done for keeping up if you are. We've got one more type of question with rationalising the denominator. This is where the denominator gets more challenging. So have a look at this question here. Can you see the denominator has 2 parts? Rather than just being root 3, we've got 3 plus root 3. Now this is a top of the higher tier topic, so please don't panic if you get a bit lost with this one, because it is top. But I'm going to try and explain it to you so it's there if you need it. Now I'm just going to rewrite our first fraction out, so I've got a bit more room to do the workings. We've got 3 root 3 plus 3 over 3 plus root 3. Now here, in order for this to cancel out, do you remember our first example in the starter where the answer was just 1? That was where the surds cancelled out, and we want that to happen. So here we multiply by something, I call its evil twin. I heard another maths teacher calling it this and it stuck with me. So the evil twin of 3 plus root 3 is 3 minus root 3. You just change the sign on the surd. Okay, so we just change that middle sign there. 3 plus root 3 becomes 3 minus root 3, evil twin. Now on the top of that fraction, remember it's still got to be the same on the top and the bottom. So we've also got to write 3 minus root 3 on the top there. Now this is where it gets slightly complicated to do. It's just using the skills you've already done, but it's remembering that this term is in brackets and so is this term. So we've actually got a double bracket multiplication there. So like we did earlier on, we've got to multiply everything by everything. I'm just focusing on the numerator for now. I'm not going to draw all my arrows in because it's going to get really confusing on your screen, but hopefully you'll be able to follow as I do it. We've got to take the first from each bracket. 3 root 3 times 3 is 9 root 3. Then I've got 3 root 3 times minus root 3. Now I know it's going to be a minus because we've got one minus in there. 3 root 3 times root 3. Root 3 times root 3 is 3, but I've also got another 3 in there. So it's actually 3 times 3, which is 9. That's a tricky one to explain. I'm just going to write it over here so you can see what I've done there. Times the minus root 3. So these ones together, the root 3 and the root 3 make 3, but I've still got 3 times that. 3 lots of that. So that's why I end up with minus 9. Okay. Then let's move on to the 3, so that's the second term in my first bracket. I multiply by the first term in my second bracket. 3 times 3 is 9, so we're now adding 9. And then 3 times minus root 3 is minus 3 root 3. So that's my numerator done. I'm going to simplify it in a minute. I'm now going to do the same to my denominator. Remember they're both in brackets. 3 times 3 is 9. 3 times minus root 3 is minus 3 root 3. Remember, if one's a normal number, one's a surd, we just write them like that. Then we've got root 3 times 3, which is going to be positive 3 root 3. Then we've got root 3 times minus root 3. It's going to be negative because there's one negative there. Root 3 times root 3 is just 3. So it's looking really complicated, but now we're going to simplify. If you look at the numerator and we look at our regular numbers first, minus 9 plus 9. Nice, they cancel out. We don't need to worry about them. 9 root 3 minus 3 root 3 gives us 6 root 3. So that's all we're left with on the top. On the bottom, can you see which bits cancel out? Minus 3 root 3 plus 3 root 3. Nice, we've got rid of our surds on the bottom, which is the whole point. 9 take away 3 is 6. So we end up with 6 root 3 over 6. Now hopefully you'll see there that the coefficient is 6 on the top and we've got a denominator of 6. So we can cancel the 6's and we just get root 3. Now I know this is right because the question was a show that. Show that it can be written as root 3. Love these kind of questions because you know you're right when you've done it. Okay? Well done on that. I understand it's really tricky and it's tricky to explain over this platform as well. You have a go then at this next question coming up and see how you do. Sorry, this is going on a bit longer than 30 minutes or 40 minutes, so do leave if you have to, but I'm going to finish the slides and they'll all be there for you to record if you need to, or to go back over. Right, have a go at this one. Sam, thanks for your comment. I'm going to try and show a bit more working on this next one. I'll rub out the previous bit, my example, and we'll go through this one all together in just a minute. Okay, just another few seconds to finish off that last one, and then I'm going to go through it. Okay, let's have a go then. I'm going to wipe the screen so I've got a bit more space for this one. I'm just going to be doing the one that you've gone through together. So we've got 5 plus 2 root 3 over 2 plus root 3. Now I've got to multiply by its evil twin. So we're going to choose 2 minus root 3 over 2 minus root 3. Now remember they're both in the double bracket, so now we need to do 2 lots of our double bracket expanding. I'm going to use the grid method for this one. So on the top, I'm looking at my numerator now, so that top row, and I've got the grid here. And in my first bracket I've got 5 and then 2 root 3. The second bracket I've got 2 and minus root 3. So when I multiply, 5 times 2 gives me 10, 2 times 2 root 3, 4 root 3, 5 times minus root 3 minus 5 root 3, 2 root 3 times minus root 3. This is the tricky bit. So we've got that 2 and we've got that minus. I'm just going to put that in for now. Root 3 times root 3 is just 3. So we've actually got to times that by 3, because remember that 2 root 3 is right next to each other. So we've actually got minus 2 times 3, we've got minus 6 there. So hopefully you can see that process and how I got that one. 2 root 3 times minus root 3 becomes 2 times 3, so minus 6. Then we can add all these together. I'm just going to write this down here as our denominator. We've got 10 minus 6, which will be 4. 4 root 3 minus 5 root 3. So we've actually got a minus 1 root 3. Okay, so I've done my numerator there, the top part of my fraction. Now let's do the bottom part. So now I'm doing this 2 plus root 3 times 2 minus root 3. Let's draw another grid. We've got 2 plus root 3, 2 minus root 3. 2 times 2 is 4. 2 times root 3, 2 root 3. 2 times minus root 3, minus 2 root 3. Minus root 3 times root 3, minus 3. So the root 3's cancel out. Now let's add together and work out what we've got. 4 minus 3 is just 1. So I'm going to have a 1. 2 root 3 and then minus 2 root 3. They cancel out completely. So I've actually got 4 minus root 3 over 1, which is just 4 minus root 3. Final answer. And again, it was a show that, so I know I've got it correct. Okay, I hope that's helped showing the double brackets expansion there. It's just remembering that evil twin. Change the sign in the middle. Okay. Right, I'm just going to show you the practice questions I've got for you now. And there's a selection here of all the skills we've learnt today. So we've got basic simplifying right at the top. We've got multiplication. We've got single brackets on question 4. We've got more of that double bracket on question 5. So that will be your grid method if you're practicing that. Then we're moving on to rationalising the denominator. Question 6 are the simple ones, 7 are the tricky ones. We've got to use that evil twin. I'm going to stop this now or in a minute, and I'm going to let you do that in your own time and look through my answers because I've got the answers all on the slides. Just want to draw your attention to also, if you're finding that really good and you're following that, then I've also got some problem solving questions here. So this is all Surds but related to shape questions. I don't know why that's off slightly. We've got ones on triangles there, we've got ratios coming up, and we've got rectangle problems, area problems as well. So you've got lots of questions there. We've also got down here details of the next session, which is going to be next Monday on YouTube still. And it'll be 5 PM on Monday, and we'll be covering all things percentages. So we'll be looking at compound interest, simple interest, reverse percentage, percentage change, all of the nasty little methods that are just the little tricky ones that we forget and then we all get mixed up. If you want any further questions on Surds, then you can download all the resources I've used today from my website, which is mrsk'slightbulbmoments.wordpress.com, or you can log on to Corbett Maths and look at videos 305 to 308. They've got videos and practice questions and solutions all there for you. Do subscribe to my channel because you'll get a notification when the next live show is coming out, and do leave me feedback if there's anything you want me to work on for next time or change slightly in the presentation. I'm all ears. Okay, I hope that's been helpful. I'll leave it here and I'll put the video up so that you can see those practice questions. Alright, well done today. Bye bye.